Everyone, welcome to solve this nice math Olympiad algebra problem. So here we have m plus n equals to 9 and mn equals to 81. So we solve this problem for the values of m and n. So first we call this is our equation number 1 and we call this is our equation number 2. So here we need to solve these two equations for the values of m and n. So here our equation number 1 is implies that here we move this m to the right hand side and we get the value of n equals to 9 minus m, and we call this is our equation number 3. So here we put the value of this n in equation number 2, so that equation number 2 is implies that this is m times of n. We have the value of n is 9 minus m equals to 81. So here we need to solve this equation for the values of m, and after that we back substitute this value and we get the value of n. So now we multiply this m on both of these terms, so it will be written as 9m minus m squared equals to 81. So this is the quadratic equation in m variable but not into the standard form. So first we need to convert this equation into the standard form. For this we move these two values to the right hand side. This is minus m square. When we move in the right hand side it will becomes plus m square. This is plus 9m becomes minus 9m. This is 81 equals to 0. So this will becomes quadratic in m variable into the standard form. So first we so here we can apply the quadratic formula in order to solve this quadratic equation. So in order to apply the quadratic formula, first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 9, and c equals to 81. So the quadratic formula is stated as m is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is our quadratic formula, and now here we need to substitute the values of a, b and c here. We have the value of b is minus 9, so when we put this value here it will becomes minus times of minus 9 plus minus square root of this b square. B is minus 9 square minus 4 times of a is 1, c is 81 divided by 2 times of a. So here our a is also equals to 1. And now here in the next step we need more simplifications, and we have our m is equals to, this is minus times of minus becomes plus 9 plus minus square root of this minus 9 square equals to plus 81 minus this is 4 times of 81 divided by 2. And now here in both of these terms you see here we have 81 with a common term, so that we will take common 81 and we get the remaining values are 1 minus 4, and it is divided by 3. So you see here this is 3 plus minus, so this is 2. The square root of 81 equals to 9, and 1 minus 4 equals to square root of minus 3. It is divided by 2. So we will obtain here the two values of m are 9 plus minus 9 times of square root of 3 into iota, and it is divided by 2. So these are the two complex values of m, and now here we need to find the corresponding values of m, corresponding values of n. Okay, so in order to find the corresponding values of n, first we need to write separately these two values. Here we write the positive value of m, it is 9 plus 9 times of square root of 3 iota divided by 2, and here we write the negative value, it is 9 minus 9 times of square root of 3 iota, and it is divided by 2. Okay, so here we just need to put this value in equation number 3, so that our equation number 3 is implies that n is equals to 9 minus m. So we put above both values of m here and we get the value of n. So first we put this value of m here and we get n equals to 9 minus m. the value of m is 9 plus 9 times of square root of 3 iota divided by 2. And here in that side we put this value of m here, and we get our n equals to 9 minus, sorry, this is 9 minus m, and we have 9 minus the value of m is this one, 9 minus 9 times of square root of 3 iota, and it is divided by 2. So here we need some simplifications. We need to take the LCM of this term. So the LCM is 2, and this is 2 9s are 18. We multiply this minus sign on both of these values. It will be written as minus 9 times of square root of 3 iota. This is the value of n, and we have 18 minus 9 equals to 9 minus 9 times of square root of 3 iota, and it is divided by 2. So this is the value of n corresponding to the value of m is this one. Okay, so here we need to focus on this case. So here we again take the LCM of this term. So the LCM is 2, so this is 2 9s are 18 minus this 2 is cancelled out by this 2. We multiply this minus on both of these values. It will be written as minus 9 plus 9 times of square root of 3 into iota. So here we need some simplification. So this is 18 minus 9 becomes 9 plus 9 times of square root of 3 iota, and it is divided by 2. So this is the second value of n corresponding to the value of m is this one. Okay, so finally we have the two roots of the given equation are, so the values of m and n is equals to the value of first value of m is 9 plus 9 times of square root of 3 iota divided by 2. The corresponding value of n is 9 minus 9 times of square root of 3 iota divided by 2. So this is the first solution set, and the second solution set is the value of m is 9 minus 9 times of square root of 3 iota divided by 2. The value of n is 9 plus 9 times of square root of 3 iota divided by 2. So this is the second solution set of the given equation. Okay, this is the final answer of this question. And now here in the next step we need to verify these solution sets, so that here I can just verify the one solution and I can left the verification of other solution for up to you. You can do the verification of second solution by yourself. So for the verification of the first solution, we need to first copy down the given question statement here, so that the given first equation is m plus n equals to 9. The second equation is m times of n equals to 81. So here we put the value, this is the value of m, this is the value of n. We put these two values on both of these equations. So when you put these values in the first equation, so we have the value of m is 9 plus 9 times of square root of 3 iota divided by 2, plus the value of n is 9 minus 9 times of square root of 3 iota divided by 2 equals to 9. We take the LCM of this term, so its LCM is 2. We get 9 plus 9 times of square root of 3 iota plus 9 minus 9 times of square root of 3 iota equals to 9. So you see here this and this term are gone, and we get 9 plus 9 is 18 over 2 equals to 9. This is 2 9s are 18, and we get 9 equals to 9. This shows that the value of m and n satisfied the first equation. Similarly, we move here to verification of the second equation. So here we put the values of m and n. The value of m is 9 plus 9 times of square root of 3 iota. The value of n is 9 minus 9 times of square root of 3 iota equals to 81. So here we can apply the square identity. We have this is 9 square minus 9 times of square root of 3 iota whole square equals to 81. So 9 square equals to 81 minus this 9 square equals to 81, and this will becomes 3, and this iota square equals to iota square, and this whole equals to 81. We will obtain here, sorry, here we have little mistake. This is divided by 2, and this is also divided by 2. So here this is 2 times of 2 becomes 4, and this is also divided by 4. So this is iota square equals to -1, and here we take commonality 1 and we get 1 plus 3 divided by 4 equals to 81. So this 4 is cancelled out by this 4 and we get 81 equals to 81. So this shows that the values of m and n satisfy the second equation as well. This is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.